Good morning, all of you. I know you are eagerly waiting to start a new chapter. Yes, today we are going to start the new chapter, that is chapter number 6, the triangle and its properties. How much you are excited to learn this new chapter? I am also excited, that much only. Okay, so let's start. So, the chapter totally deals with the triangle, a new shape, because in the previous chapter we have done how to find out the area of the triangle. But this chapter we are first going to know about the triangles. Then after knowing about the triangles in this chapter, that chapter number 11, that is perimeter and area, will be more clear to you. Now the triangle. So first of all, can you tell me what is the minimum number of line segments required to make a close figure? At least how many number of line segment we require to make a close figure? Yes, you are right. That is, we require at least 3 line segments to make a close figure. So, can you name me what is the name of that closed figure that is formed by the 3 line segments? What we can form by joining the 3 line segments? What is the name of that close figure? Yes, you are very right. That is triangle. So, you can easily see here a triangle is a closed figure. So, what is a triangle? A triangle is a closed figure having 3 sides. A triangle is a closed figure having 3 sides. It has 3 vertices. It has 3 angles. So, what I have told now about the vertices, angles, side, these are the properties of the triangle. So, what is triangle? Triangle is a closed figure having 3 sides. Okay, now I am naming this vertices. Let it be A, B and C. So, what will the property of this triangle? What I can get from this triangle? Okay, first of all, you have learned about line segment, so you can easily see which are the line segment present over here in this triangle. Yes, so those line segment actually the side of those triangle. So what are the sides of this triangle? We can easily see we have 2 endpoints, so these are not lines. It is a part of line which is having 2 endpoints, so we will be naming that as line segment. Okay, so AB one line segment. So now you recall, you have learned how to denote or indicate any line segment, how to name any line segment, how to name any line, how to name any ray, you have learned. So which symbol I have to use here so that it directly symbolizes AB is a line segment? Yes, we are going to use a bar over that. That denotes AB is a line segment. But here in this triangle, it is also the side of that triangle. So what is the other side? AB, BC, AB, BC and CA. So these are the sides of the triangle. Now next, can you name the vertex present over here? Vertex are the corners. Vertex are the corners of any closed figure. So what are the corners you are getting here? One corner A, next corner B, this is corner C. So they are the vertex A, vertex B, vertex C. Now one more thing you have learned in the 5th chapter about the lines, angles. So using lines we make angles. Okay, angles formed by the intersection of two lines. Okay, angles are formed by the intersection of two lines. So here, can you get what are the angles present over here? Angles concept is very much clear to you, I hope, because we have already learned. So what are the angles we can see here inside the triangle? Angle A, angle B, angle C. So can you name that angles? So you will be writing angle A, angle B, angle C. But it will be more proper if you mention the angle totally. Okay, so what is that angle A? So this angle A we can write BAC, angle BAC. The middle part denotes that angle BAC. So which is the angle forming by BAC? This angle A. So it will be more proper if you write angle BAC. It can be also written as CAB also. Okay, you can start from there also, CAB, but since we are going to denote angle A, set angle A, that A symbol should be in the middle. These two can be interchanged. Okay, so next, angle B. Angle B, what can you write for angle B? So this angle can be also written as CAB also. So now see, lines and angles chapter can be more clear from this also. After learning about triangles, lines and angles, then your perimeter area, many chapters will be more clear to you. Okay, now angle B. Angle B. So what I can write for that? ABC or CBA. Anyone you can write. So angle ABC, or you can just interchange and write CBA. B should be in the middle because that angle we are going to denote. Okay, next C. So angle ACB, angle BCA. You just match with the figure. So these are the few things related to triangle. Okay, now we are going to learn many more new things about triangles. These are the basic: side, vertex and angles. Okay, so let's see what new thing we are going to learn about triangles. Now, I hope you know you have learned about different types of triangle. Yes, you have learned about different types of triangle. You have learned scalene triangle, equilateral triangle, isosceles triangle, then acute angle triangle, obtuse angle triangle, right angle triangle, many types of triangles and their names with their properties you are knowing. But what is the basis of classification of those triangles? Why we have done so different, name those different type of triangle? So there must be some classification rule based on which we have classified into different types of triangles. So what is that basis of classification? So triangles, in triangles, just now we have saw there are sides, there are angles. Those sides can vary in size. Those sides present in the triangle can vary. Even the angles in that triangles can also vary. The vertex will remain the same only. Vertex will not change. Okay, vertex will remain that only. But we can increase the side of the triangle. We can decrease. We can make any of the two sides equal. Anything we can do. Similarly, angles can also be changed. We are making this type of angle. We can change this to this angle. We can change also. So angles can also be changed. So based on two things we can classify triangles. First, depending upon the sides, and next depending upon the angles. So triangles can be classified based on sides. And again, triangles can be classified on the basis of angles. So, two criteria for classification, one side, another angle. Okay, so now based on side, how we can classify them? So based on sides, how we can classify them? So if you consider all side of different value, all side of different measurement, what we call that type of triangle? Yes, you are very right, scalene triangle. Scalene triangle, where all the sides are different. Next, if I keep two sides equal in measurement and the next other side, the third side is different value. Only two sides equal, third side of different value. So you know the names, but you don't know the classification based on which it has been classified. So these are the basis of classification, based on side, based on angles. So based on side, if all sides different, scalene triangle. If any two sides equal and the third side different, isosceles triangle. Okay, now if all the sides equal, that very easy, yes, equilateral triangle. Now, based on angles. So angles I've shown now just how it can differ. From acute to right angle to obtuse angle, it can differ. It cannot be a straight angle. In a triangle, one angle cannot be a straight angle. If I make one angle as a straight angle, can I join the third side? These are the two sides. This is the vertex. These are the two sides, making 180 degree. Third side I can make. Can I join with the third side? Then the third side also lie in this line only. So, if the angle is 180 degree, we cannot make. Okay, so we can make up to obtuse angle. We cannot make straight angle. A triangle cannot contain a straight angle. You may prove in another way. We know sum of all angles equals to 180 degree. So two angles cannot be 180 degree. So there will be no third angle. We know sum of all the angles of the triangle. This property also you are going to learn. Sum of all the angles of a triangle, angle A, angle B, angle C. If we add them, we must get 180 degree always. Angle sum property of a triangle. So if I make one angle, not only two angles, one angle only I am making 180 degree. Okay, so one angle only I am making 180 degree. What will the value of those two angles then? No value, zero value. But it cannot happen, then triangle will not form. So you can just give the reason in this way also. Okay, so maximum we can vary angle up to obtuse angle. Acute angle it can be, right angle it can be, then obtuse angle it can be. But we cannot extend up to 180 degree, that is the straight angle. Okay, so now based on the angles, we can classify them as three types. What are they? If the angles inside that triangle are all acute angles, less than 90 degree. If all the angles inside that triangle are all acute angles, means all angle value are less than 90 degree. What we call that type of triangle? Acute angle triangle. Acute angled triangle. Next, if one of the angle is obtuse angle, then obtuse angle triangle. At obtuse, okay, one of the angle is obtuse angle. Obtuse angled triangle. If one of the angle is 90 degree, if one of the angle is 90 degree, yes, the name related is right angle triangle. So this is the classification of triangles based on sides, based on angles. Okay, scalene triangle, isosceles triangle and equilateral triangle based on side. So below this, if you don't know the meaning, you can just write it down. Scalene, where all the sides are different, are having the different measurement. If two sides are having the same measurement, we call them isosceles. All the sides equal, equilateral. All the angles acute angle triangle. One of the angle obtuse angle, then obtuse angle triangle. One of the angle right angle, that is 90 degree, right angle triangle. Okay, so if you don't know the meaning, just you write down below this. Okay, now moving on to the next topic. A new term, a very new term related to triangle. Okay, let's move on to that. Now, yes, you can see here median of a triangle. A very new term. Yes, you have very much familiar with this median. Yes, data handling chapter. We have done many central tendencies calculation, mean, median, mode. Okay, so median is having a common meaning also. So here also something, that meaning will fit here also. So that time in data handling chapter, what is the meaning of median there? Even mean, median, mode having some common meaning. We name all the three, mean, median, mode, with a single word. What is that word? Or can you tell me where the mean, median, mode lies? There is a set of data and we have arranged that data, because I have told whenever you get any data, you first arrange, organize that. That is our first step towards solving any data handling problem. First, arrangement. After arranging any data, where the mean, median, mode will lie? Generally, where it lies? Yes, generally it lies in the middle. Generally it lies in the central part of the data. Okay, so we together call them mean, median, mode as central tendencies. Okay, now central, that word is very much related here also. Median of a triangle. So here also something median will lies. Yes, you can guess it, right? Inside the triangle or in the near about the center of the triangle. Yes, it is like that only. So name is related. Although median of a triangle is totally different from what we have learned in the data handling chapter. But the word, the meaning of that word is very much same in both the cases. That is the central or center. Okay, or the middle. Now, what is a median of a triangle? What is the median of a triangle? So let us draw a triangle because it is related to triangle. So let us draw triangle. Okay, and we can name that triangle as A, B, C. You can also name, not always we will use A, B, C. You can use PQR, you can use XYZ, any naming you can give. Okay, so we have named the vertices, we have named the triangle. Now, what is a median? What is a median? So, before going to that, you must know what is a midpoint. What we call a midpoint. So, midpoint, what is the meaning of mid? It is again coming from the word middle only. Midpoint. So, middle point. Mid, that word is coming from the middle only. So midpoint means middle point. So if there is a line segment, PQ, so it is of suppose it is of 10 centimeter. So where will be the midpoint of this line segment? Where is the middle point? Yes, if it is a 10 centimeter, you will make half of that. So that will come 5 centimeter. So 5 centimeter from there or 5 centimeter from there will be our middle point. And that is the midpoint only. This M, if I name this point as M, this M denotes the midpoint of line segment PQ. What is the midpoint of line segment PQ? M. Okay, so you have just to half that line segment. So where you will get that point, that will serve as a midpoint of that line segment. Okay, so here also, before coming to the median, we must know midpoint. So I hope midpoint is clear to you. Middle point of any line segment, that is the midpoint. So how many line segments we can see here? Yes, 3 line segments we can see here. So how many midpoint we can just assume, or we can just guess how many midpoint will be there? If there are 3 line segments, how many midpoint? So if I consider one line segment, how many midpoint it can have? A line has always one midpoint. A middle point we cannot plot. If there is a line segment, only one midpoint we can tell. The midpoint cannot shift here. Then if the midpoint shift here, so this is not the midpoint, because these two parts are not equal. Okay, so midpoint always lies in the middle. So how many midpoint possible for a line segment? Only one. Yes. So how many midpoint possible in a triangle? Since it is having 3 line segments, so 3 midpoint possible. So let us take BC. So whatever we keep in the bottom, that line segment serve as the base. We call generally, since BC in the BC we can take here for this triangle as the base. Base means always base. That word you just correlate with any other thing. Base always represent the lower part. Okay, base of the house, then base of the book. It is always base word denotes on which the rest of the thing is standing. Okay, so that serve as the base. So here we can take the base as BC, because on that we are making that triangle. So BC here is going to serve as the base. So now can you find out the midpoint of BC? So you can just cut a paper or a triangle from a paper. Okay, cut a triangle in a paper. Now you just fold the line segment. You just fold that part. Okay, how you have to fold? You take that C corner on the B. So now you fold the paper. So you will get something line over here. Okay, when you open that paper, you will get some line. Okay, after that, you will see some point you are getting or some intersection you are getting at BC. On the line BC, you are getting one intersection. Okay, that will be our midpoint. So I am naming with M only here. So that will serve as the midpoint. So you can do with the paper folding. Cut out a triangle from a paper and you just take point C upon that B. Okay, C should coincide with that B. So you are folding that triangle. When you will fold, so make that to make a line, you press that part. Okay, after pressing you just open. So you will get this kind of line. or impression you will get. Okay, so you will see that impression is also cutting that BC. So that point will become our midpoint. Okay, that point will become our midpoint. Now, because that will be, now you can, with the help of the scale, you can just measure how much is BM, that value you measure. Okay, that value you measure and this value also you measure. You will see both the values will come equal. Both the values will come equal. Then M is the midpoint. Okay, now, so midpoint is clear. So in this way, how many midpoint we will get? We can get midpoint here also. We can get midpoint here also. So now, what is a median? Median is a line. Median is a line from a vertex. So we can consider, first we are considering this vertex. Median is a line from a vertex to the midpoint of the opposite side. From a vertex to the midpoint of the opposite side. We cannot make, this is our vertex and this is our midpoint. This vertex is opposite to this line BC. So two things we are going to consider. First, a vertex and the side opposite to that. Which side we are considering opposite to that vertex, that midpoint we will consider. So when we will join that vertex with the midpoint, that will be our median. So here AM is our median. So what is a median? Median is a line from the vertex to the midpoint of the opposite side. To the midpoint of the opposite side. So median is a line only. Median is a line only. A line from the vertex to the midpoint. Which midpoint? Because we have midpoint here also, we have midpoint here also. So to which midpoint? Midpoint of the opposite side. We cannot make from a vertex, it is a line from the vertex to the midpoint here. That will not be a median. Median is always obtained by joining vertex and the midpoint of the opposite side. Opposite side is very much important. So we cannot join A to this point. We cannot join A to this point because vertex A, what is the opposite side of vertex A? BC. Opposite side of vertex A, BC. What is the opposite side of vertex B? What is the opposite side of vertex B? AC. So what median we can get for this? So it is a line from the vertex B to the midpoint of the opposite side. To the midpoint of the opposite side. Here value of this equal. Here also value of this and this equal. So we are denoting with similar sign. Okay. This part, I am naming that point as N. So this part equal to this part. So you can show like this. This part equals to this part. You can show like this. Single line, same line. Okay, so it denotes value is same. Here also two lines because this is not equal to this, not always. So we have to use different sign here. So two lines I am using here. So two lines here also because this part length equals to this part length. So similar notation we have to use. So in this way, if I consider this vertex, what is the opposite side? This, and midpoint this. Take is at O. So again we can draw a median from the vertex C to the midpoint of the opposite side. So here how many median we got? AM, then BN, then CO. So you may be asked, how many medians are possible in a triangle? How many median possible in a triangle? So you think, how many median possible for a triangle? So median, once again I am repeating, median is a line from a vertex to the midpoint of the opposite side. What is the opposite side of that vertex? This side. So I have to find midpoint there, then I have to join. Okay. So median is a line connecting vertex and the midpoint of the opposite side. Vertex and the midpoint of the opposite side. Okay, vertex and the midpoint of the opposite side. Okay, I hope median is clear. If any doubt, because this is a very new thing, if any doubt you ask in the DCC. Okay, now these three questions for your homework. Now you have knowing what is a median. So what is a median? You have to define. So you have to write the definition. Explain with the diagram. With the diagram you have to explain. So how I have explained with the help of a diagram. Same triangle you will make. Then you will make a median. Now you will explain what is the median you are getting there. So explain with the diagram. How many medians can a triangle have? How many medians can a triangle have? So I have already shown, so you have to just get that concept. Indirectly I have shown before only. Does a median lie totally in the interior of the triangle? A median, so a triangle has two parts. Actually a triangle is having two regions. So first, this region inside that triangle is called the interior of the triangle. Inside the triangle, the region inside the triangle is called the interior of the triangle. And region outside the triangle is called the exterior of the triangle. Okay, so very much clear. What is the interior of the triangle? The region enclosed by that uh, line segment of the triangle, and exterior outside the triangle. Okay, so very much clear. So does a median lie totally inside the interior of the triangle? Always median will lie inside the triangle, or it can lie outside also, does a median lie always inside the triangle? That line you're drawing for finding the median is always inside the triangle. So you draw or cut different types of triangles: scalene triangle, isosceles triangle, equilateral triangle, obtuse, acute, right angled, all the 6 types you draw. Then you cut. Then you find median of all one triangle. How many median? That you will tell. For the each triangle you will draw. So 6 triangles, 6 types of triangle you are getting. So you draw all the possible median in those all 6 triangles. Now then only you can tell. So after experimenting only you tell this answer. Does a median lie totally inside? So in all the 6 cases, are you finding all the median inside the triangle, or you are finding any median outside the triangle also? Then you share that answer. Okay, so this is the homework from the median part. Now we are going to introduce one more new word related to triangle. So let's see. Yes, so now a new term related to triangle is the altitude of a triangle. So you are very much known to this word, altitude. You used to study that word in geography. Yes, in geography you have studied, I think, altitude. Yes, altitude is related to height. Altitude is height only. Okay, so what is the height of a triangle? Altitude of a triangle. How I can find out altitude of a triangle? So here also, so as I have told, what is a base of a triangle? The lower line segment is we generally used to call as a base of the triangle. Okay, because the whole triangle is standing over that BC line segment. You can also make this AC also base. So when you will make AC base, so this will be, so AC now serving as a base. Similarly, AB also can serve as a base. So you have to just rotate it and you have to form the base. Okay, like that way you can make 3 bases from this triangle. Now, what is the altitude of a triangle? Altitude is a line from a vertex to a point in the line BC. So here also, just like median, Here also we are going to consider a vertex and the side opposite to it. What is the common between median and altitude? When we are finding altitude or a median, we always consider the vertex and the side opposite to it. What is the side opposite to vertex A? BC. So we will consider BC, not AC, not AB. BC we are going to consider. So this is the common between altitude and median. So don't confuse. Only this is the common thing. So what is the difference between median and altitude? Yes. Now it is a line, altitude is a line joining vertex and the opposite side. So I can make many number of lines over that. So I can make many altitude, but these all are not the altitude. What is the altitude here? So according to the definition, it is a line from the vertex to the opposite side. But one more thing we have to mention, it should be perpendicular on that side BC. So it is the line from the vertex to the opposite side, and that line must make 90 degree with that side. So this line and this line should cut each other at 90 degree. Then only we will consider that as altitude. Okay, so here what is the altitude? So we are not going to consider all the lines which are joining vertex and the opposite side. Only we are going to consider the line which is joining the vertex and the opposite side, and it is cutting the opposite side at 90 degree. Then only that will serve as the altitude. Height. Whenever you are talking about height, that is always the perpendicular line. It is not a slant line. Height means always you measure vertically. You cannot measure as a slant line. So here also we have to measure the vertically. How much is the height of the triangle, altitude of the triangle? So how much is the distance of A from that D? So we have to measure vertically. We are going to measure that vertically, not in a slanting way. Because the height word only itself telling, every time when you measure height also, but when you are measuring height, okay, in school you used to do, but this time it is not possible. But at home you have measured your height and you have given the data also to the class teachers. So how you have measured? You are standing like in a slant way. How you have measured? What the teachers told you? When you are going to measure the height, stand straight, because you are going to measure the vertical. So you cannot stand like this. You cannot stand like in a slanting manner. You have to always stand straight. Okay. So height means always you have to measure vertically. Okay. So same, height means altitude. It is another name for that. So AD is our altitude here. How many such altitude you can get? You can now consider AC as a base. If you consider AC as a base, so this is the vertex. What is the opposite side to B? Vertex B? This side. So when a line perpendicularly falls, so this is also BE also serve as the altitude. Okay, when AC is the base. When AB is the base, similarly we will get only one difference between altitude and median. So each must cut at 90 degree, because these two lines must make 90 degree, but in median it is not always making 90 degree. Okay, because if I draw this type of triangles, So what is the median? So midpoint of this will lie here. Okay, and we have to join the opposite vertex to that. So is that a vertical line? No. So median can be anything. It can be a vertical line also, it can be a slant line also. But here always vertical height. Okay, so 90 degree should be there. So this is the difference between altitude and median. So here also we can get CF also as the altitude. So how many such altitude possible in a triangle? I hope you got the answer. Next, you have learned what is the exterior and interior of the triangle. So altitude always lie interior of the triangle, or it can lie in the outside of the triangle. If I give one I am having a triangle like this, P, Q, R. I am going to calculate height from this vertex P. So what is the vertical height? How you can find out? So after extending this RQ, you can just get that vertical height. So this is our triangle. This is our triangle. Okay. Now this altitude PL. Let PL be the altitude, making 90 degree with this opposite base, opposite side of, or what is the opposite side of P? RQ. So it can be extended. Then only we can draw that altitude on 90 degree. So now from here you can see the altitude can lie outside or it is always inside. So from this picture I hope you got your answer. So now few questions for you. So you have to think, you draw, you make, at least you make 6 triangles, 6 type of triangle. Before only I have discussed based on sides, based on angles, 3 3. So total 6. So of both types, okay, both classification, you got 6 triangles. Okay, you cut out 6 types of triangles. Okay, from a page you take a bigger size only. Now you make median and altitude of each and every triangle. Then you answer all these questions. That will be very much clear to you. Okay, now I'm giving few questions on altitude. So here few questions. First, define altitude of a triangle. How much is the height? You know how to define that. It is not the median. So what term to include there? So you just read the book. You will get what is the definition of altitude and you have to explain with the diagram. Okay, how many altitudes can a triangle have? So it is clear from the before only what I have drawn there. So you think over that. But it will be better if you practice by a paper cutting, then you answer this question. Will an altitude always lie in the interior of the triangle? So this hint I have already given. Always altitude is inside the triangle or it can be outside the triangle also. So if you experiment with paper cutting and if you find after folding what is altitude, what is this median, then only you can answer this. Okay, so after doing, then you answer this question. Fourth, name a type of triangle. So you know 6 types of triangle. Name one of the type of triangle in which 2 altitudes of the triangle are 2 sides of the triangle. We generally what we see, altitude is the separate line. Okay, so when there is a triangle, altitude is a separate line. But in the question it is asked altitude will be the side only. Altitude will be the side only. In which type of triangle you will get that? Altitude will not lie inside or outside. Altitude will lie on that side only. For which type of triangle? Okay, so that is the question. Now few more question, that is the comparison between median and triangle. Based on that, few questions are there. So here, this is the common questions between median and altitude. Those are the question. First part, it is based on the median. Second, I have given part that is based on the altitude. Now combining both of them. So first question, what is the similarity between median and altitude? Already discussed in the video. What is the similarity between median and altitude? What is the difference between median and altitude? So from the definition only you will get the difference. What is the difference between median and altitude? Third question, can altitude be the median? In a triangle, altitude can be the median also. Mean the same line is the altitude also and same line is the median also. Can it happen? If it is happening, if yes, then in which type of triangle you will get that? Median is the altitude only. In which type of triangle? If it is yes. Okay, so do these questions. I hope you will enjoy the homework questions today. Okay, so try to do the practicals, then you try to find out the answers. Okay, so thank you. This is the introduction part. So next day we will continue from exercise. Okay, from first exercise 6.1. Okay, thank you.